Okay, for question B, the circuit now is connected in delta connection. Okay, this is the slide of correction for the slide that I have uploaded before. So this little mistake regarding how to calculate the RA. So I have do again the slide. If you accidentally have viewed the previous slide, please ignore the video. So please refer this video as our recent or valid discussion. Okay, so now we are connecting in delta connected system. So for delta connection, you can see here our V phase and V terminal are at the same values. So V phase and V terminal, V phase here, V terminal share the same values. So V phase are equal to V terminal values. But in terms of current, I phase here, I that flows through our RA here, it's not the same that the current that comes from the DC source. So we have performed this DC test. We provide 10 volt, we measure 25 ampere that goes into the circuit. So these 25 amperes are separating between RA, this arm, and RA of the upper arm. So means that the I phase of the individual RA now is equal to I load divided by cert 3. Okay, I load divided by cert 3. So if you are calculating the equivalent R that flow or on the available on the branch, so for R that we see from here, the equivalent circuit of R equivalent or RDC equal to VDC divided by IDC. The VDC we apply divided by IDC, so we get the R equivalent or RDC is 0.4 ohm. Meanwhile for RA, so you can see here it was a delta connected. We have a delta connection, so RA is equal to RDC. That we can see from the outside here, from the equivalent circuit from the DC source, is equal to 2RA parallel with RA. So the 2RA here parallel with RA. The 2RA here parallel with this RA. Okay, we have equal to 2RA parallel operation times RA divided by 2RA plus RA. Means that we shall have a 2RA squared divided by 3RA. So you must cancel RA with RA. So the remaining will become RDC is equal to 2 over 3 RA, or RA is equal to 3 over 2 RDC. That's what we have now. Or we put in the values, become 3 divided by 2 times 0.4, so it becomes 0.6 ohm for RA. RA is equal to 0.6 ohm. Okay, 0.6 ohm. Then we shall find the internal impedance of the system, ZS, which is equal to RA squared plus XS squared, which is equal to internal generated voltage divided by armature current, EA divided by IA. But at rated IF, we found that the V phase open circuit here is equal to V equal to the V terminal. equal to V terminal, which is 540 volt. 540 volt. Delta connection, the V phase equal to V terminal. Meanwhile, I short circuit here should be divided by circuit 3. Should be divided by circuit 3. It's equal to I load short circuit divided by circuit 3. So we have here 300 ampere divided by circuit 3. We shall get how much? Just now 173.2 ampere. Just now the voltage, phase voltage. This is your phase current, 173.2 ampere. So the Zs is equal to Ra squared. So Ra just now we calculate 0.6 squared plus Xs squared here plus Xs squared. So is equal to 540 divided by 173.2 ampere. So we calculate for this so we calculate the equation. 0.6 squared plus Xs squared equal to 540 divided by 173.2. So we solve for Xs, we shall get Xs squared is equal to 9.362. 9.362. So we set the answer, we shall get 3.059. 3.059 ohm of Xs. So Xs is 3.059 ohm. 3.059 ohm. So this is Xs and Xs. Sorry. So the Zs is 3.118 ohm. So we calculate already for Zs, Xs, Ra, Isc, V open circuit. So all obtained. The Ra, the Xs here, Zs here, and Ia. Then we put in again on all the related calculated data into the circuit. So here are 0.6, and all other parameters should be inserted into the circuit. So that's the procedure or the steps that you should perform once you get the question. Instead, all the questions transfer to circuit, and from the circuit you can produce the equation, or you can imagine, you can visualize what is where, and you draw the delta or Y circuit, you derive the equation as well. Then you insert all the parameters to calculate the result. If not being asked to comment, so you just publish the data. If it being asked to comment, so please comment or describe accordingly. Okay, thank you for this discussion for part example 4.1, part A and part B. So we shall see in the next slide for next example discussion. Thank you very much.